Quality Management Committee meeting Thursday, April 30th. Will come to order. First item on the agenda is the Oyster Symposium discussion. Karen Doucette and Jay Duella were booked to come here and tell their tale, but I spoke to Jay this afternoon and he regrets to inform us that he is not coming this afternoon. So we'll try him again when he and Jay are available. Which brings us to Mike McGrath, a well-known character in Falmouth, who has been immersed in wastewater for longer than all of us put together.
That's a good way of putting it.
These are just, I'm going to show boards, and these are copies for what I'm going to show.
Women's coming in the door. So.
Oh, good.
Nice.
Okay, so Wayne got one? Because one's
Yeah.
second. Thanks.
Where is
Good afternoon. My name is Michael McGrath. I'm going to tell you today, or make some recommendations on how to approach fixing our estuaries. And the first thing I got to say is that I congratulate the committee. I have to hold the selectmen. I thought you did a great job getting approval of an adaptive management plan through EOEA. And I will now go to my own opinion. My own opinion is that you're doing a great job for a committee that basically has one hand tied behind their back because of the process, and then the other hand is constrained because of the collie approach. So I'm going to first go over my bona fides, and by that I mean I'm going to explain to you my experience, what gives me the right to come before you and make these kind of recommendations. The current model was actually developed in 1984 in Falmouth, the models that are currently used to assess nitrogen. In 1985, I built the first alternative innovative septic system, a residential one in Davisville. It was called a ruck system. The concept of the ruck system is you put, at that time, black water on the top, and the bacteria that exist naturally in the sands convert the ammonia and the organic nitrogen into nitrate. So then after it comes through, you mix it with an available carbon. The first rock systems had split plumbing. The carbon source came from the detergent. So I gave you one of these. It just says that this is what's in the raw wastewater. There are bacteria that convert to NO2 and NO3. If you have carbon, bacteria, time, and temperature, you can get free nitrogen. Denitrification is the only effective way to get rid of nitrogen. There's one out of order. Hopefully yours are in the right order. And what I did was I blew this up. What's denitrification? You have nitrate coming in, you need available carbon, you need time, temperature, bacteria, and no oxygen. This can be anoxic or anaerobic. I don't know if you really know all that, but it's also for the benefit of the public that might be watching. So you have copies of all of these. One of the most interesting papers that I've read in the last few years, there's two soil scientists named Cleveland and Litson, and they identified what's called a Redfield ratio for soil bacteria. This is a quick diagram of what they found. They reported that the Redfield ratio is 60 to 7 to 1. 60 carbon, 7 nitrogen to 1 phosphorus. Redfield, that should sound familiar to you. There was a scientist in 1957 that identified in the marine environment that there was a certain ratio of carbon to nitrogen to phosphorus. Lipscomb and Cleveland measured it only in the upper 10 inches. We're down in this zone. The carbons might most likely be slightly less. But when I looked at that and I read that paper, it was, aha, this explains a whole bunch of things that happens. And one of the things that happens is that we as a society, and it's ubiquitous, we take and we treat the water to the highest possible level. It's easy to get rid of organic carbon, the readily available organic carbon. So, for instance, your own treatment plant, they always have some quote-unquote BOD. What I did here, for explanation, is I took BOD of 10 and total nitrogen of 7. That was, I grabbed a sample from a wastewater treatment plant. So what I did was, BOD doesn't measure total organic carbon. That's probably about 3. So graphically you have 7 carbon, 7 carbon, 7 nitrogen. Yes, 3 nitrogen, 7 carbon. Now, you put them, it passes by these soil bacteria. There are millions of those in a cubic centimeter underneath a plume of a wastewater system. And they are what they eat. So if you give them 7 nitrogen and 3 carbon, they're going to consume all the carbon. They might consume one of the nitrogen. And what happens? You get all nitrogen. That's why we get nitrogen plumes. So what I have done is I've taken this and I've actually added basically one of these filters at 2 small-scale treatment systems. I took the treated water, I added carbon, and lo and behold, I got more removal. So when I look at what my hypothesis is, my concepts, my ideas, there's actually 2 different types of nitrogen pollution. I'm going to call one virulent nitrogen pollution. Virulent nitrogen pollution is it's nitrogen that's discharged into the groundwater and it has not sufficient amount of carbon. And there's examples. Nitrogen plumes for commercial wastewater, nitrogen plumes from cesspools, nitrogen plumes from landfills, nitrogen plumes from wastewater treatment plants, nitrogen plumes from fertilizer application, especially agricultural application, and nitrogen pollution from agricultural feedlots. The highest groundwater level of nitrogen that I've seen was underneath a agricultural feedlot. It was something like 25 parts per million of total nitrogen. What happens is that over and over again, if you look at these, they're generally, there's not enough carbon to offset the nitrogen. And this is the kind of nitrogen pollution that will travel miles and with virtually little loss of the mass of the dissolved nitrogen. In reality, there's always carbon dropping down. It's about 1 milligram per liter after most rainstorms of carbon, but it just doesn't really affect these in any way. So, for instance, at the north end of the Chesapeake, at one of the state lines, they have between 8 to 10 parts per million of nitrate in the groundwater. It's coming from the agricultural uses upstream. Wastewater treatment plants, we've already seen my little description. You know that your own wastewater treatment plant has a plume, especially from early on when it didn't denitrify. Nitrogen plumes from landfill, that's been documented by a microbiologist and hydrologist named Tricia Chappelle. Commercial wastewater. 1984 model. Your hands are tied behind your back. They assume that all uses of wastewater are 50 milligrams per liter. I have 2 commercial buildings, I'm not going to tell you where, they have 200 milligrams per liter of total nitrogen in the raw wastewater. Between the CVS on Data Straits and the school building, we have a commercial wastewater with a significant flow. It's 183 parts per million was the first test of raw nitrogen, and the second test was 186 parts per million of total nitrogen. That's like 360% more than what's assumed. When I did Little Pond Landing, I did a nitrogen offset, and I found that the total nitrogen coming out of the Falmouth Trade Center was 190% more than assumed. So the 1984 assumptions about wastewater came from treatment plants. What I say is we can make the nitrogen what I'm going to call addressable. I made these names up. You shouldn't hear these names except from me. And what I did is addressable nitrogen is discharged dissolved nitrogen that will be attenuated, or there will be a gradual loss of dissolved nitrogen in the groundwater over a long distance. Addressable nitrogen pollution is a source of nitrogen being discharged in the sands of our soils, accompanied by the dissolved carbon in the correct ratio. There's a paper by Valiela et al. That he did. He tracked the plume of a leaching pit in Wacoit, and he found that I think within 600 feet there was significant attenuation. There's a septic system in Nova Scotia called a contour trench system. They discharge the raw wastewater on a very shallow sand filter. It's only a foot deep, but it's discharged on top of a 20-foot impermeable barrier that slopes down at 10%. There's concrete sand basically on top of that. And in 20 feet, they lost between 63 and 75% of the total nitrogen. Attenuation exists. There's a paper by a graduate student named Sean Farrell. He found that the nitrification and denitrification occurred on top of basically when you discharge, ignore this for a moment, if you discharge wastewater from a septic system, there's a bacterial cloud, and he found that the nitrogen transformations were occurring on top of the biomass. That's a brand new paper, less than 6 months old. So what I have done is I have broken things down, and I've told you how to do things in my mind, and or what my recommendations would be. And there's 3 different approaches. The first thing is the regulatory approach. The most important thing is that we all have to work for the same thing. Every town board that gives out a permit ought to be focused on how to fix the estuaries. It's our most important and valuable environmental resource. And unfortunately, there gets to be an attitude that, the water quality management people are studying this and we don't have to worry about it. That's probably true in Mar Vista and Falmouth Heights, where we're going to put in sewage, but there's other places. So I wrote here a bunch of steps. I'm not sure it's under this step or the next step, but the most important thing to me is no matter where a septic system is, you measure the raw nitrogen. Whenever there's going to be an inspection or a building permit of any type or a repair, you measure the raw nitrogen.
So you're in data collection.
That's under data collection. Yeah, that's the next sheet. But I thought I should start out with that because you're going to be amazed. In 2009, I wrote a report. I filed with DEP. My RUC systems, I use an organic carbon made in Bourne, Massachusetts for a carbon source. I'm the only system that consistently uses a carbon source after nitrification. I guarantee 80% removal. I have some of the removals are much higher than that. So as a result, I'm the only one that can tell you what the raw wastewater number is. 2009, I filed a report with DEP that says my raw total nitrogen is 80 milligrams per liter. 160% more than assumed. I also did a report I filed with DEP about the raw nitrogen in a shared system of 60 houses. It was 140% more than what's assumed. So anyways, the regulatory approach is that what we should do is determine what is an appropriate distance, and anybody that gets a significant permit near the water should put in a nitrogen reducing alternative innovative system. And my attitude is that the engineer should pick whatever system he wants. There are some that work, some that don't, but the owner and the engineer have to be responsible for its operation. I think that Maryland is currently using 1,000 feet off the Chesapeake. If you have a septic system within 1,000 feet on the Chesapeake, you have to put a denitrification system in. What's different about their approach is they list the performance, actual performance from the on-site systems on their website. You could waive the requirements for some landowners who have very significant marshes. I guess 75 feet, I don't know enough, to be blunt. I haven't tested that. I don't know. I picked 75 feet as a swag. Scientific well, something, yes. The denitrification system should be put in every time there's a conveyance, a building permit, a septic repair, or a significant land use permit. I drew this one to explain the next one. If you have a denitrification system, you have a soil absorbent system, you should put an irrigation well in. The irrigation well is going to be critical because that's where you really want to test the water. You want to put the screen in such an area that you catch where his plume would be. And you should measure that. You're going to be spraying that 9 months a year. You'll get an additional reduction if it's done right. Within 100 feet of an estuary, well, probably within more like 600 feet of an estuary, total nitrogen should be below 12. Somehow you have to make sure that there's a vertical and horizontal barrier so that surface runoff doesn't reach the estuary. You could do that with simply a trench that would be 3 or 4 foot wide that's full of mulch. You want to intercept all the surface runoff. You are constrained because the drainage. Your drainage waters have nitrogen. I don't have any real tests. I had one. It was a long time ago. It was 20, but it was in the first flush, 20 parts per million of raw nitrogen. The assumptions that are made to date is that the nitrogen comes from the sky is what reaches the estuary. Excuse me, you look at what happens in a gutter, there's organic matter. So you're going to need to test that, and you need to work on that. You need to require that anybody puts a system in that it has to work. And if it doesn't work, make it work. Every system's got an operator, and I'll tell you what, I can make almost any system work. So they have to make it work. I say stop requiring nitrogen fixing plants to be installed as mitigation along the banks of the estuary. Pet peeve of mine, when I did Little Pond Landing, I measured the total nitrogen in all different wells in the background, and one of the highest numbers was the shallow groundwater. There's 2 feet of recharge a year. This isn't a sand pit, so there's more than that. But in the upper 2 feet was 3 parts per million of organic nitrogen. When you walk up and down and look at the plants, some of the plants fix nitrogen. We still are requiring that some of those woody indigenous plants be installed along the banks of our estuary. Put them out on the dunes, out on Vineyard Sound and on Buzzards Bay. But don't require them along the banks of the estuary. apparently I don't know what I'm talking about with the answer. Encourage the use of shared denitrifying septic systems. Basically, the more flow, the better off you are. I do operate a big shared system, and it does work better. What I've said here is that, you know, there's now a carbon that you can add to wastewater treatment systems to make them work. I believe that we could add carbon to the final effluent. In Bourne, there's a company called Environmental Operating Solutions. I was a founder. I resigned 10 years ago because I'm a good engineer, but a terrible businessman. And you probably never heard of Environmental Operating Solutions. But they've sold enough carbon to have denitrified something like 23,000 tons of dissolved nitrogen. So right here on Cape Cod, there's been things that people don't understand or don't, you know, that there's been advances in denitrification. All right, the town should map the groundwater. The reason I say that is the groundwater is, it's going to reflect the tides.
Where are you here?
Data collection.
Data collection. Unless there's a regional approach to this, that you could easily screw this up if you looked at it. The groundwater actually is out of phase with the tides because of the, well, basically the friction in the groundwater. I've done it, one study where I found it was at the entrance of Oyster Pond, where at high tide, the groundwater was pointing towards Vineyard Sound. At low tide, it was pointing up the pond. It was near the entrance. It was Lenny Beffett's house. Some of you know where Lenny Beffett lives. So I did a groundwater study a long time ago, and when it was pointing upstream, it was high tide and the groundwater was low, and then it was just completely out of phase. USGS scientists said that that was consistent with what they found. I got an A in that paper. So anyway, like I said, require that every time that there's either a permit or an inspection or a significant permit, we need to get the raw nitrogen measured. One of the things that's implicit in this, if you go up to some place like, you go up by 151 and you get 100 parts per million of denitrification, you really should make them denitrified, because that plume is going to go a long way. When you dose raw wastewater on our soils, and it has very high levels of nitrogen, there's a phenomenon that the bacteria that attack the ammonia, they're pretty strange bacteria. And what they're doing is they're very strong. They're breaking a bond between a nitrogen and hydrogen molecule. They release hydrogen, so it gets acidic. And so the bottom line is that when it gets too acidic, they stop working. So I have run into this a couple times in residential systems, and now a competing firm was operating a RUC system, and after like 9 years, it stopped nitrifying. I told them how to fix it. You have to adjust what they call alkalinity. I identified the triggers for measurement. I said they have to have the testing done in a DEP certified lab. I did a whole bunch of tests with field tests, and when I went and had them calibrated in the lab, they were never close enough to rely on. We need to measure the total nitrogen in the drain water. So you're going to have to do that The way you do that's with a composite sampler. The composite sampler, I should have brought you a picture. It's a cylinder about that high inside of the bottle that probably holds 5 gallons. You suck out about 1/48 of what the sample is every half hour. You can change the settings too. But the bottom line is you get the average over the storm. And then I said, if you have a large data flow outside the agent with very high total nitrogen concentrations, then it should be treated. Funding. What I basically said is, we need, if somebody does this, if someone on the water does this, they ought to be treated as heroes. It's funny, we have a funny attitude. I have a system out there that the raw wastewater is 80. They consistently get between 8 and 10 parts per million discharged, and yet we had a project that went before another town board and it was denied. To me, those people are heroes. They put that in without being told to. By the way, I forgot. Yours says that if there's under regulation, if someone's put in a denitrifying septic system, don't punish them. In other words, someone that's already put one in, they should be under an amnesty. What I'm saying here is you need to figure out how much money. You create a fund, you basically lend them the money, they pay it back over time, 0% if they get to 3. If they don't get to 3, you increase the interest. It's sort of self-replenishing. You may have to have a state law to do this, and it's going to take the town meeting to, basically raise some bonds. But I submit that that's cheaper than the current approach, which is you gather all the wastewater up, put it in pipes, and then you pipe it miles. And there's going to be other places that you're going to need the sewer based on the lot size. And so I think it would be far cheaper to do this. And the other point is that you're asking the people to help you solve this. It's not just the government. When I look at the most effective things we've done, we've involved getting the people. The perfect example is the 300 Committee. A small group of people got together, they went to town meeting to raise some money. The people continually voted to buy open space. It was the best thing we ever did. So now, to me, there's a way to do this. Now, I understand that you're going to be limited, but I would hope that you bring this to town meeting, and I hope town meeting would consider it seriously, because this is our town, and this is our resources. And I think that if we enlist and enroll the people, we'll be a lot better off than the current approach. So I'd be happy to answer any questions about my opinions.
Any questions about Mike's opinions and experience here?
I'd like to thank you for taking a systems approach to the thing, to thinking of the whole thing.
English is anguish to engineers, and see it helped.
Yeah. Okay, I just want to try to feed back to you what I think I learned from your presentation about the way nitrogen behaves in the soil. It was curious that, number one, you don't have any denitrification unless you have sufficient carbon. The less carbon you have, the less denitrification you have in the soil.
That's right.
Secondly, nitrogen is much higher than we think it is in coming out of septic systems and so forth.
That's right.
And thirdly, and this is the one that interests me most because there's been a lot of controversy about it, that even under present situations, if you go far enough back from the water and you put nitrogen in there, there will be large amounts of denitrification over distance. The distance means denitrification.
The way that you look at it, if the nitrogen was discharged into the vadose zone,
Yeah.
accompanied by carbon, there will be attenuation. It takes a long time. It takes quite a distance. carbon to nitrogen ratio in septic systems is always positive, meaning there's more carbon than nitrogen. The trouble is we don't measure the carbon direct. We measure a thing called biochemical oxygen demand, or 5-day biochemical oxygen demand. That's a constituent that was developed in the early 1900s. It basically tells the sanitary engineer how much air to bubble through a reactor vessel to get rid of the organic, readily decomposable organic matter and some of the chemicals, for instance, the ammonia. But the relationship between BOD and TOC is very vague. So in the contour trench system, the ratio is about 1.2.
But
I don't know what the ratio is to get attenuation.
you were saying, it seems to me you were saying, in Maryland, for example, they have the rule, if you don't have to do anything if you're 1,000 feet away.
More than
from the
1,000 feet away.
More than 1,000 feet away, because they believe that there will be substantial denitrification. If you have that much time to go through the soil, there will be substantial denitrification.
Well, the other thing you could do is look at your own drinking water wells.
Yeah.
The background in Cape Cod of nitrate is between low detection to 1, and the highest drinking water well you have is 2. I sent a chart that shows most of them are, well, I have it. If you give me a minute, I can find it. But the bottom line is, we have hundreds of houses north of some of these drinking water wells. Why isn't there more nitrogen? I'm not qualified. I don't have the right training to figure out exactly what the real recharge area is. But I did take the assumed formula, and I get a lot more nitrogen than what exists. However, I got to tell you, it needs to be done. I suggested several times to be done. But
Mike, I don't think anyone is claiming that if you're 1,000 feet from a resource, that you're not contributing to the nitrogen problem of it. In other words, we can't simply go 1,000 feet back from each one of our estuaries and say anybody that's in back of that line isn't contributing to our problem. What I think the Maryland people are saying is that if we deal with the ones from 0 to 1,000, we're getting the stuff that's easiest to get at. It's not letting, one shouldn't lead the public to believe that if you live a mile away from the resource, that ultimately you don't contribute to the problem.
well, I would believe that if whatever nitrogen is left, if it was discharged with the right amount of carbon, whatever nitrogen left is recalcitrant, or it's not going to break down, is the way. The key that I look at as 3 parts per million has been identified by several people as the key threshold of the highest nitrogen that an estuary can, well, in the groundwater, can drain to the groundwater without causing problems. So that's why I picked 3.
Just to go back to that one more run through. You say that, were you saying that there is enough carbon in the soil naturally,
No.
so that if you put something a mile or 2 away from the estuary, or a mile away or 2 from the intake for one of your fresh water wells, that houses that are that far away from it will not contribute very much to it because there is slow attenuation over that period. Is that what you're saying? Or are you
Yes.
saying you do have to put extra nitrogen, extra carbon in order to get that attenuation?
I would say it, let's describe it this way. I have, in 1988, I was the design engineer, or my firm was a design engineer for the reconstruction of the town marina bulkhead. And when we, the way the bulkheads work, I should marker, was that there are piles driven. If this is the bulkhead, there are piles out here, and then buried in the ground, there's piles here and there are cables called tidal rods. They're really solid rods. When we replaced this bulkhead, we required the contractor to uncover the sediment. And when we did so, he was excavating below the groundwater. So, in the south of the current building, when he was down into the groundwater, he was pumping so the groundwater was seeping in. We encountered the plume from the cesspool of the cesspool that then existed at the harbor master's office. And what was interesting about that was it had while the edges were vague, it was no wider than a small pickup truck and was maybe two basketballs high. It was very flattened, looked like a flattened garden hose. And it smelled like raw sewage. So my point is every septic system generates a plume. And what happens is we don't remove all of the carbon when we discharge onto a soil absorbent system. And so what happens is that some of the carbon reaches the groundwater and then slowly degrades over time. Out at Otis, I was trying to do a pump and treat where I was pumping water from a bag. At one end was a Tidal 5 trench, at the other end was I was pumping it out, adding carbon, putting it back in. And when I shut it, I didn't get low enough total nitrogen to make it impressive, so I abandoned it. When I shut it off, the total nitrogen, I shut it off and I slowed it down. And the total nitrogen coming out of it dropped by 75%. It dropped it for a while, then it went back up. What had happened was, in the top of I caused, in the pump and treat portion, I caused the soil bacteria to die in the bottom of them, the bodies of them, and the stalk rained down and degraded over time. I've captured that material. The other thing that happens is under every septic system, there is a cloud of anaerobic conditions. When we measure water in nature, we measure total organic carbon dissolved, particulate organic carbon. We measure total nitrogen, total phosphorus, pH, dissolved oxygen, etc. We don't measure total solids except during the process. And out at Otis, there was a long abandoned bed, and it was abandoned in 1995. In 2004, they found it was still anaerobic underneath. There's anaerobic water conditions underneath some of our ponds and wetlands. And so I assert there's anaerobic conditions under every septic system. So every septic system can be an eraser for the nitrogen coming through. So it's a combination that the carbon is in the plume. The carbon gets used a couple times, and that's where the attenuation comes from. The fact that carbon escapes septic system is easily understood because of pharmaceuticals and some of the personal care products that we're finding in the groundwater all the time.
Any other comments about
Yeah,
that?
I have a few questions. Yeah, thanks to Mike for the presentation. In your studies, the first question is, when you took the measurements, those high measurements and various ones, that was sort of at the outflow point from a leaching field or outside of a cesspool or something? Was it near that, or was it further away?
I'm sorry, the first part of your question.
First part is when you measured the nitrogen in the groundwater, and you came up with those figures, was it near it was sort of what's coming out of the system?
No, let's put it this way. The nitrogen concentrations I have in the groundwater, I don't have that many data.
Okay.
I do have scattered pieces of data. The nitrogen that I measure is the nitrogen in our wastewater in the final effluent, and that's what we measure all the time.
Okay.
So before it gets to the leach field.
All right.
Yeah.
It's
Okay.
a pipe coming out of the house
That's called raw wastewater.
And that's where you measure it?
Yes, that's where I measured it. That's,
Okay.
a lot of times I measure from the downstream end of the septic tank.
Okay, have you seen the MT Environmental Restoration Report on the Athabasca Peninsula study that was done on groundwater and nitrogen and other? Have you
The
seen that?
bottom line with why I'm saying you should measure the
Yeah.
groundwater direction is I did see that. However, remember, the plumes aren't very wide. They're only as wide as the septic system. So it's very rare that you will intercept a plume. I've intercepted a plume a couple times. I intercepted one in Yarmouth. There was 8 parts per million, probably. I don't know how far away the septic system.
Well, this was a very limited study, a very, starting one. And the nitrogen concentrations they found basically in the groundwater range from 0.13 to 1.3 milligrams total nitrogen per liter. And they did a calculation of and they also found that in the area they were measuring, that the groundwater flow was quite slow. It was like 32 to 77 feet per year lateral flow. And then they did a calculation of a transect that was 5,000 feet long by 50 feet deep. And they estimated through that in that area from this limited study, and they could have missed a lot of things, that only about 140 kilograms of nitrogen per year was actually going through it. And they could have missed a lot of things, but they did do several depths in the freshwater lens. So I don't know if this, one other point was that the total dissolved organic carbon was 1.2 milligrams per liter as compared to, say, 0.13, or the highest was 1.2. So it's like almost like 1-to-1, say, with the nitrogen. If that in the groundwater from the report. How does 1-to-1 work with denitrification potential or something? Is that gonna, from your experience, is that gonna work?
The way that when I dose, I have a filter that I've developed for adding to treatment plants. It's small scale at the moment, and it's much more than 1-to-1. In order to get, I get removal of half. It's a filter like that. I'm taking highly treated by, I'm sorry.
Oh, okay.
I take denitrified fluid.
Mm-hmm.
Denitrified fluid has generally less than, in Yarmouth, where I developed it, it has about 7 to 8 parts per million of total nitrogen, and there's very little VOD. So I add highly available carbon to it, and I dose it periodically, and I can get, well, for a while I was getting 3 parts per million. So I was getting almost 60% removal of low concentration. So I captured at the bottom after a hurricane, I captured strange material. It was a USGS guy eventually helped me identify it as the cell walls of the soil bacteria. And he thought it colloidal. I didn't want to touch it. He was right. It's colloidal. I didn't.
So,
Well,
Mike, the easiest way to explain this to the public, the reason that in all of these wastewater systems we have to augment the carbon in order to get denitrification is the fact that when we as animals break down food materials, we split the carbon in half. Half goes into building new body material, and half we respire as CO2. And that's why we excrete nitrogen in our urine, because the balanced food that we eat is half respired and half going in. So there's an excess of nitrogen. And that's why in all of these systems, we have to figure out how to augment that carbon again in order to take the nitrogen to zero. And that you know, we're doing that in huge, big treatment plants where we change the alkalinities because we need to increase the pH, and we add carbon. And we do the same thing in these little alternative systems by adding wood chips. That's a slow-release carbon source. And what Mike is doing by adding carbon. So that's basically the reason that we have this problem, and these are the ways, through a whole variety of scales, that we address the problem.
Yeah, thank you, Mike. That's a good talk. But you must be very frustrated because you gave the core of this talk to us about 2 years ago, and we haven't done anything with it.
No, that's not, no,
Well,
you have got sewers going in America, you got sewers going in Falmouth.
Oh, no, I didn't say we haven't done anything. I meant with this specific idea. Right?
No,
I don't think
I
we-
didn't go to you, I went to town meeting direct saying, measure the total nitrogen. And
He did come to me.
Well, what I'm
He came
getting
to me.
at is, I mean, I'm somewhat the layman caught in the middle here. If George Heufelter was here, what does he think of it?
I don't know, you'll have to ask George. I've learned
Good question.
George won't tell me how he feels about things because ethically, he cannot tell me, for instance, is this
And-
system working, George?
And what about DEP?
Who's tied your hand behind your back?
Well, I mean, I'm trying to
Who's put the other
remove,
hand here?
I'm-
Who refuses to recognize things like landfills?
I'm trying to remove the frustration factor and say that what seems to be missing to me between a potentially good idea that's almost still in the laboratory stage, or in the pilot stage, to going to a town meeting thing, voting to apply this to the whole town, would be some kind of demonstration project or something. And what would you propose along those lines? Or am I completely wrong?
Well, to be blunt, one of the reasons I'm here is about 3 years ago, I called a guy in an environmental group at not Massachusetts, but another bay. And I said to him, how's your bay going? He says, we're involved in another blankety blank study. McGrath, will you please do something to stop the endless studies and let's get started? So Maryland is ahead of us. And all I can say is that I was told by one association where they've now have a scientist before, he told me that I had a PhD level paper to prove that attenuation exists. And I almost said to him, well, you know, there's no PhD level paper that really asserts that attenuation doesn't exist. Attenuation exists. I'm utterly convinced. I did do some work on groundwater, and I don't get the kind of levels that is modeled there.
Just, I'm sorry, Mike, for another question, but,
No, hey, I'm here
okay.
because this is my town.
Let me see if I can distill this down. If we were to take your recommendations, you would say, test everybody's septic system when it needs to be cleaned out or it needs to be replaced,
Inspected,
inspected,
building permit, transaction.
okay. And if it has high nitrogen levels over,
Well, what you're going to end up doing is having a database. What I said, let's say, for instance, is a commercial site up on Sandwich Road.
yeah,
And if they have 140 parts per million of total nitrogen, they're going to have nitrogen that is going to go a very long distance because that water is so strong that that most likely there's not enough alkaline.
okay, so you had some kind of chart that said if you're 140 parts per million and within a mile, blah, blah. So anyway, you rig up this chart. So then you're saying, then it's their responsibility to put in a new septic system that removes the nitrogen, a nitrogen removing septic system.
Those are the estuaries and then the ones that are very high strength wastewater along distance. And they have to be big flows, not houses, but
Not houses, but commercial.
Yeah.
Yeah, okay.
Some
So,
of the commercial numbers have just been amazing. I told you, 200 milligrams per liter. That nitrogen from that system is going to go on.
yeah, I remember we talked about that earlier, last time you were here, and we tried to figure out why. I mean, is it more concentrated? Is it smaller flows, or, I mean, it's hard to,
Water saving
is it all urine? Is that
fixtures,
it?
no. In 1995, when they adopted the innovative systems, they also changed the plumbing code, so everything is low flow. Everything is low flow. So one of the things that's happened is the concentration's gone up. And it is much more difficult to treat some of the waters that we see. When I get over 100 in a rock system, I get very worried about alkalinity. The alkalinity will run out of simple. Alkalinity means that it will stop converting the ammonia to nitrate at some point because there's so much acid in the sand. It'll stop.
Jerry?
I think you'll agree with this, that based on the commercial measurements you made, maybe in and around Little Pond, in your own knowledge of a lot of individual septic tank systems, that most people would agree that the 35 milligram per liter that DEP asserts for coming out of a home is very low. I would say, and people keep on challenging me, that if the sewers don't, they will reduce a significant load, if not most of the load. But the sewers in Little Pond, not that there's sewers every other place. The project we have going on in Little Pond will remove a significant amount of nitrogen based on the conservative estimates of what we think is coming out of individual septic tanks, not to mention a couple of commercial businesses that you know of.
Well, I think you well know that when you first started, at one town meeting, I stood up and said you had to sue these. And then I
Yep.
wrote a letter for the last town meeting that you voted the money.
Yep,
saying
thank you.
You had to do this. The lots are too small.
Yep,
The other point is that you have a large amount of cesspools.
yep.
When they built cesspools, they dug them down to the groundwater. So they never failed.
Okay.
The only trouble is 100% of that ammonia reaches the estuary.
You're a little.
The other thing, Mike, because the hour is getting late, is that I think Ron and I would disagree, as well as the authors of that paper, on the groundwater at Capacit. They said they had limited data. It was a very rough estimate, and you shouldn't take those numbers to the bank. The numbers were calculated, they showed us how, but it was clear that they had few data points, and it was a very, very rough calculation.
That's fine, and Mike said he hadn't read that report.
But I'll send it to you.
In
But
detail, so let's not
Remember,
worry about it.
if an average monitor well has got a screen of 15 feet, well, the plume is only 2 basketball courts high. So if you have, 12 feet of clear water, 1 part per million, and then you mix in some attenuated nitrogen, you're going to get the wrong kind of reading. What you need to do, and I said it, is you need to have the screens up high because the plumes are up high. And if you remember, I said that because you need to focus on, you have to understand where the plumes are. They will dive with depth. But anyways,
Thank you.
I've done a little work on groundwater, but I'm not qualified. I'm not a high qualified.
All right, well, thank you again. Stick around, because the next piece of the agenda relates to a big part of what you put out here in terms of the question of funding. How do you pay for that? Steve has been taking an initiative on this because his specialty is Oyster Pond. Oyster Pond is a situation where everybody around Oyster Pond isn't necessarily going to be treated the same or pay the same. And how you fund a nitrogen removal plan that works and that's fair is the subject of Steve's initiative. So you're on.
Well, it's not much of an initiative so far. I had a fascinating meeting yesterday with John Waterbury and Peter Boyer, and I don't know if they enjoyed it as much as I did, but I had a great time. And I basically wanted to get this issue out on the table for everyone on the committee to be thinking about, and hopefully some smart people in the town. First of all, I want to divide all the approaches we've thought about into two groups. There are what I would call estuary-wide approaches, like inlet widening, oysters, and permeable reactive barriers, things that are not associated with any particular property, and no one remotely thinks that any particular property owner would pay for it. And then there are the things, eco-toilets, advanced IAs, and sewers, which are connected to specific houses. And people definitely think there would be a role for the homeowner to pay for that through some mechanism. So for instance, if you go to a community meeting and you ask what people favor, you'll always get someone who stands up in favor of the estuary-wide ones for merely the reason that they know that they won't have to pay for it out of their pocket, completely regardless of the technology or how effective it is. But that it doesn't take a rocket scientist to figure that out. And you also hear, I think it's in print, and people on this committee have said, when we propose something like inlet widening or oysters or PRBs, that it will reduce the amount of sewering required. Okay, so by definition, that means that in some watershed, less than 100%, but more than 0%, would presumably need sewers or IAs or alternative toilets. So that means, at least in theory, there may come an issue of deciding who is in the 60%, who's in the 40%, or the 50%, or whatever it is, the 10%. And how do you make that fair? I've heard some people say, the heck with fairness, just pick some people and tell them to do it. I find that hard to believe, but I have heard it. And the mechanisms I've heard of are, one, create sewer districts and spread the cost over the entire watershed, so that the people who don't have to do the specific thing and those that do are both paying for it. Two is adjust the betterment and so on, and things like bylaw changes, so that the perceived cost for those in the do group versus those in the don't have to group are approximately the same. Two is just come up with some, and this may be what makes this whole thing a moot point. Perhaps in all the watersheds, there will be some physical difference between one shore and the other shore, or the northern part and the southern part, that makes it obvious which ones have to do it. But then you still have the question of how to do the paying. And then a lottery has actually been proposed, but that's controversial as to whether that's acceptable. Or there might be some clever auction system where you pay to not be the one to put in the expensive part. But that's all I know. I'm just interested in other people's opinion.
Just a quick question. Steve, in the things that the individuals, you said it, the assumption would individuals would pay for in betterments? Was that the idea, or?
In some means, I don't want to limit it to something.
Okay,
I'm
but
just
did
saying-
you include eco-toilets in that group?
Yes, you
Oh,
did.
yes.
Yes, he did.
Okay, okay, that was just,
And of course, as with Mike's idea, you could take any of those and totally subsidize them, so there is no cost to the homeowner. But from what I've heard about betterments and so on, for some reason politically, perhaps that doesn't fly.
well, we've talked about this, and for the sake of just, reminding the committee about it, eco-toilets do not qualify for betterments. It would require a change in legislation, and it may even require a change in federal legislation, because ultimately it's money.
That's
A lot of the money we get is from the feds, and I think they put the requirement on it. And so,
When you bring up a really good point, that a lot of these require perhaps impossible legislation, or difficult legislation.
Difficult.
Or long.
Difficult.
nothing's impossible.
Nothing's impossible. The
How
town's
big the
had
check
some
is to the
experience
government.
With this very topic, with the low-pressure people in Mara Vista and the Heights, whose cost of installing a system to hook up to the sewer is going to be greater than for the people with gravity systems. And so it's half of them are going to be doing the one, half of them the other. The town took as its goal, let's equalize in the installation costs for both parties. They found that the bond council said, you can't use, well, first of
Yeah,
all,
yeah.
SRF said, you can't use your 0% loan to hand it out to the folks who have the low pressure problem. The bond council said, you can't use town money for that unless you get special legislation, which we did. So the town now has special legislation in place which says, if the town wants to help these particular people by subsidizing their added cost to join the sewer,
They can.
it can do it because of the special legislation. But you couldn't do it with the SRF money.
Yeah,
Uh,
good.
and
Just
you couldn't
if
do it
there-
before you get the special legislation.
Quick clarifying. If the town or public entity owns the eco-toilet, owns the IA system, and is responsible for operating it and maintain it, that's the biggest hump to come over for being eligible.
Right, it's
Septic
gotta be a
tanks are
public-
one thing, owning someone's, it may not be that far of a push. It would be along the lines of a sewer district or septic management district. I think the other thing is few people truly understand betterments, and what you need to do is bring someone in so you all understand how far you can go with betterments and the reasons why, even if you don't disagree. So you'll know the type of legislation you'd have to do. For instance, we can't do betterments within a watershed totally if everybody in that watershed is not being improved by an eco-toilet sewer or whatever. You could come up with some other type of tax or whatever. So I mean, if you need to understand betterment, so you figure out how do we take that apart or try to fix it.
It has to be publicly owned.
Well,
Yes, yeah.
Yeah, there's got to be a particular benefit to that particular property.
Correct.
I mean, so that's part of the problem.
Could you own and lease?
Here,
DEP, I tried that with the grinder pumps, and they don't particularly like lease.
For the low pressure, we went over the vineyard and we saw where the town
Right.
owns them, operates them, fixes them. In that case, it's not a problem. But in this town, the policy decision has been made, the town does not want to own them, operate them, or fix them.
They won't go on the property because of...
They don't
That's
want to
right.
set foot in the property at all. So if that's the policy, then you got a financing problem that you wouldn't have otherwise.
Just one point, because we do have a real issue facing us ultimately coming, hopefully soon, and that is with the Bournes Pond Inlet widening. That's a real example. And with that project, we are apparently going to be reducing the need for between 273 and 400 homes to would otherwise be on a sewer if it were to be sewered.
Right.
By doing that, then the remaining 700 homes would actually have a higher cost than if there wasn't the inlet because of the common facilities, like pumping stations and all those things that would need to be covered by those others. Maybe fewer pumping stations, but it is possible that the cost for the remaining homes may be higher than if we didn't do the inlet widening.
Unlikely, but possible.
So,
Because
yeah.
there's fewer people
Because that's
I wouldn't make it
to share the common cost.
Right.
So I think that this is important. I mean, we have to move it. We should be moving ahead, looking at that as a real example at the moment. It's unclear now because we don't even know if we're going to sewer that much of it, or if it could could be IA systems or eco toilets or oysters as well, even then. But the ones remaining, I mean, if we couldn't do it then. But this is an equity factor just like well, in a way, the grinder pumps, because it's,
I would, I think when we go to assumptions, what would occur, when and where? There might be a scenario if we widen the inlet, and then we have to go to some type of other solution. To then boldly say that those people are now paying more because we put in an inlet widening project, I will say is unlikely, and I will assert it won't happen, because you've reduced the nitrogen, you're reducing how the nitrogen is being taken out. If you come up with a costly system to remove the nitrogen versus eco toilets and something like that, the costs go up appropriately. But, we'll remove 1/3 of the nitrogen, therefore the remaining people, the scope of the remaining solution becomes less.
Steve's issue, which is a good one in Oyster Pond, practical scenario, suppose you sewered part of it.
Yep.
And that was enough to bring the nitrogen down to the acceptable TMD
Yeah.
level. The people who are being sewered are obviously paying for that.
Right.
The people who aren't are paying nothing.
They're paying
We're
their
all
property.
getting the same gain, right?
Well, whatever the percentage is, his solution would have been
So what do you
the
do with
betterment there could be 50-50. But it's not just the people in the watershed. The betterments, if you use betterments, go to everybody in town, not just to...
Can you do that?
No.
They call it betterment, is that-
No, the state share, I'm sorry, the town share.
Yeah.
We come up with the cost, let's say it's $100. We say the users are going to pay 70%. Everybody else in town, including the users, pay the other 30%. What he's suggestion is we have a system of recovering revenues solely based on the watersheds you live in an appropriate mechanism for taxing them or charging them for living in that watershed, whether it's a revolving fund, like you say, where violators contribute.
That's what we're sort of talking about.
But I think it was justified to the Little Pond community that the betterment equivalent was basically that for the cost of replacing a septic system or a leaching field, so that it's, in a way that if some were on the sewer and they would pay a betterment, the other
Right,
ones
they
were
do
in
have
a
a
septic
save-
system.
they do have a
Then they
saving.
would have to ultimately put in a new leaching field or something
Yeah.
like this. So, I mean, those are the kinds of things you need to balance out. It may not be it may not be equal, but it might be close. So I think that the betterment isn't necessarily just this charge on top of what it costs to live there anyway. So I think
That's true.
that needs to be factored in.
And if you want to worry about equity some more, who gains the most by having the pond cleaned up? The people who live on the waterfront gain more than the guy who lives 500 yards on the other side of the highway. They both happen to be in the watershed. Should they both all pay the same to be for the improvement?
We'll let the Mass Legislature figure that one out.
Well, if we wait for that, we're going to have to do it first, like we do everything else around here. Like,
One of the things you gotta be careful of is that some of the people cause a bigger impact than others.
Right.
A perfect example is cesspools. I can bring someone and show them a couple of areas where there's this green slime in a tile flat, and that's coming from a cesspool. That's an assertion by me, I don't have real proof. But there's a firm in Mashpee that can prove it. And the issue is that they have a much greater impact. I did do an assessment of a system in another region, and I proved that there was human wastewater affecting a stream. The stream is increasing 0.5 part per million, and the stream was not, when you looked at the total nitrogen in the estuary, it was over 1. And so we had this constant impact from one cesspool that was significant.
Mm-hmm.
So you have to really understand what these are, and the way it works right now, you don't seem to be able to understand the differential
Correct.
points. but they're real and they can be significant.
But can I ask Mike a question? But I don't want to put words in your mouth, but it almost sounds like you're suggesting treating it like a law enforcement, like a criminal investigation.
Parking
And I don't
tickets.
see,
Parking
I don't think
tickets.
any- no, I don't mean that they're actually committing a crime. I'm not claiming
Non-criminal.
I'm saying that you're saying, it sounds like you're saying, go around and find the worst offending septic systems and fix those.
That's what he said.
That's what he said.
And,
But I'm not treating it like a criminal.
all right, sorry, I sometimes go off the wall with analogies. But I
Partial regret.
all right,
I'm just thinking of my
I
clients
take
wanting
back,
me
I take back obviously my analogy backfired. But we agree, you are saying go around and find the worst offending septic systems and fix those. And of course, on one level, how could anybody argue with that? If it ain't broke, don't fix it, and if it is broke, do fix it.
Correct.
But is that really a practical public policy?
Why wouldn't it be?
Well, because, for instance, I've heard the costs of monitoring, for instance, in the study that was done for Oyster Pond, one reason that sewers came out as less expensive than IA, which is counterintuitive to a lot of people, was because it turned out there are apparently substantial monitoring costs, routine monitoring costs, to make sure that IAs are performing correctly. And I'm the layman, I don't want to get into the details of that, but it just seems to me that a search and fix option might have practical problems.
The way you would deal with that would be
I'm
to say,
trying
Title V has a shortcut, which is
Mike,
do a
you
assessment
need to see the numbers to understand his statement.
like the one he described. You pass. You go have Title V inspection that passes. And that is a real flaw in the system because it allows for the worst performing homes to pass.
But they're failing on nitrogen contribution.
But the Title V, it doesn't care about the nitrogen contribution.
Well, we could fix the law, or try
We can
to.
fix the law.
We could
Well-
we can almost fix that within the town.
Yeah, that's what I
You
was
would
saying.
have
We
to-
can,
the
we
standards
can,
are
we
good.
can declare a nitrogen-sensitive area and change the criteria for systems.
Okay, well, that would be the way to go if you wanted to do
The
that.
Board of Health can do that.
Yeah.
Yes.
Yes.
Okay.
Or you take it to town
We
meeting.
need to work together. We need that every town board has the goal of fixing the estuaries. And not in this town. There are some systems that don't work. I had a system, 90 milligrams per liter came out of the innovative system. Well, let's see what happens. I sent it to DEP, I sent it to the local town board, nothing happened. Yet, on my systems, if I guarantee 80% removal, so if I don't get 80% removal, I come back and fix it. So we need to have something there. But the bottom line is, my point is, if somebody's causing an adverse environmental impact, and we can prove it, they should fix it. There shouldn't be any ifs, ands, or buts, because it might well be that if that you could take out a huge amount of nitrogen. Remember, if the cesspools in the groundwater, 100% of that nitrogen will eventually reach, and it's instantly available.
Yeah, I mean, case in point is if, for example, I wanted to get into the county loan program to finance my eco toilets before I had the fire. So, and they said, well, you have to fail. You have to have a failing septic system. I said, well, it's not. It works. It's, I mean,
Right.
is the nitrogen output failing? It doesn't come into
Title V
play.
doesn't
And-
care.
and
Right.
John, I don't know if the Board of Health has ever even thought about that, but if we could go back to the county, and this might require legislation too, but just to say that if somebody wants to upgrade their system to meet nitrogen reduction requirements, why not give them this low-interest loan? And why put that artificial?
I mean,
That's
one-
But it isn't like the Little Pond area now, more or less blanketly declared failed system, all systems are failed?
Yes.
Right.
It's a blanket thing. So
Well, it's a
like-
blanket thing because we're requiring sewers per
Right, but-
CWMP.
But could we go further and just say, all systems in Falmouth are failed?
That's
basically.
Board of Health issue.
Well, especially if
It would be
it,
normal
It would be a
legislation, it may
nitrogen
take something to do that.
It could be done.
I mean, I think one of the things, getting back to Steve, is that if we wanted to, it would take a lot of discussion to say, if you're within 500 feet, or whatever it is, 1,000 feet, we don't care whether we've got to it or not. If you need to upgrade your system, you're going to be required to put in 3, 5, or 10. And then maybe the town will say, we'll give you 10 years before, if sewers ever come, before you have to tie in. But there's some places in town that's never going to happen. But if you can pick a magic number to say, if you need to replace it, you got to meet, let's say 10. That seems to be acceptable. 5 is arguable, okay? That gets to what Steve is sort of saying, you know, if you're within the 1,000 feet or 500 feet, but that's going to take town meeting action.
I understand that Wareham has actually put in place legislation like that, and they're going to talk about it. I think it's on the 20-something of May.
27.
Yeah.
I thought we did it already in our special legislation. We had
What's
the
that?
checkerboarding.
No, something
They're
where people,
requiring
they're requiring any new construction, any,
New
you know,
construction to have D9
must,
systems.
must-
Regardless of a TMDL or anything else.
regardless of anything.
Yeah.
It's been brought up several times in Wareham, and it's not yet, Joe Costa, I think, has been pushing that, has not yet passed.
I thought it had
Actually,
passed.
it has passed, but the board that's in charge has been giving it variances rather freely. So he's not as thrilled as he might be.
And I think the case, I mean, boards of health do have the authority to declare an area nitrogen set, but it would seem, politically in Falmouth, that's a non-starter. 5 people on a board are not going to mandate that the town of Falmouth is declared a nitrogen-sensitive area. If the Board of Health were to take that to town meeting, and town meeting were to approve that, then I think that's a viable process.
Yeah.
But I don't think it's fair to ask a Board of Health, an appointed
do
board,
townwide.
to do
It's a
that.
policy, it's a major policy.
Sure.
But
And then you have to talk about how it's going to be paid.
Well,
how
that's
it's gonna-
exactly right.
how-
Nobody's going to vote for it unless there's a big fat subsidy connected with it.
Or some way of having everybody pay for it.
Exactly.
The town of Mashpee requires denotification of any flow over 600 gallons per day, commercial. So we have
Oh,
a few in
okay.
town that already requires it for commercial flow wherever you are in town.
Mike, I have a question for you. We decommissioned, when we built onto our house, we had to decommission our old septic system and put in a completely new system. There were two, there was a cesspool and an overflow system, and probably both of them were down to groundwater. How long do they continue after you have decommissioned them? How long do they continue to feed the system? How long is it before they dry up?
I don't know.
Well, in theory, they're pumped and filled with sand.
Right.
So, the source, at the point at which you fill them with sand is that's the
There's
end
still
of the
stuff
soil.
there down below, but it's
it's in the
not that
bacteria.
much.
It's heading for the water, and like the plant here, 7 years or 8 years or 9 years later,
Oh,
the
yeah.
tail end of it
Well,
gets there.
of course, that's true, but ours was within 100 feet of the water, so that was
You're probably
Jerry,
know by
who
now.
does that?
all done.
What's that?
Who fills the septic tank with sand?
It's part of the permit.
Right.
So in other words, when you
So the
replace.
homeowner's responsible.
Oh, yes, the homeowners, just, Board of Health oversees abandoning the old septic tank when you
That
tie
have been
in.
true 13 years ago?
Yes, anytime that you replace
We
a
didn't
Title
have-
V system,
We didn't have that required.
in theory, you have to abandon the old system.
You probably should do it for
And-
liability reasons, if nothing
Yeah,
else.
it's just structurally, you don't want caving in.
We didn't have it required of us. One of them simply sat there, and the other one, they broke the top and didn't fill it.
Oh, they crash, yeah.
I didn't know anything about it at the time. I didn't know what we had to do. but No one required us to do it.
Yeah.
Way back, 68, 72.
Yeah. So if you didn't do that, you're in big trouble.
And you just admitted it to everybody on
Yeah.
TV.
Right.
Well,
I'm telling
we'll
you.
have to do it then. We'll go have to do it. but,
Marshall McGrath
There's
is going to
there's
get
there's your criminal one, right here.
I'm the furthest thing from
No, this is a conversation that we're going to have to get into
Right, later.
at great length and in great detail, and if we wait for the legislature, it ain't going to happen. So we'll be doing it here. And,
Well, thank you.
and I appreciate you kind of bringing it forward, because it's coming.
It doesn't just apply to Oyster Pond. It could apply, and I just wanted to get people thinking.
No, but Oyster Pond's the next one in the queue as far as figuring out ways to make things work. So this is a good conversation to have. Report of members and staff, we have a quick one on the dredge schedule. Little Pond dredging will commence May.
Yes, the second week of May, Board of Selectmen approved the authorization, the Water Quality Committee recommended up to 12,500 from Article 17. The Board of Selectmen approved that on Monday night, and the dredge is scheduled for the second week of May.
This is an inlet, just inlet dredging?
This is just inlet dredging per their permit that they have.
Maintenance
There's no
dredging.
time of year restriction. It's what Greg talked about the last time he was here. I don't know if you were at that, maybe you were absent. But when Harbor Master, yeah.
It's a slightly larger area than they had previously been able to do, which is good.
Yes, just for
It's a win-win.
longevity's sake.
Right, and the interest of the committee was that if we're going to have the shellfish program going on, we want to make sure that there's some
Flush.
flushing going on, because right now there's none.
It's an estuary, not a pond.
Right. TMDL for Little Pond and inlet calculations, maybe a brief comment.
Very brief. There was some discussion about the impact of inlet widening, and I just wanted to remind the committee that we did a TMDL, targeted watershed plan for Little Pond. And in that targeted watershed plan, GHD had calculated the nitrogen removal from the inlet project based on the MEP report. So from the MEP report, reading these MEP reports is complicated. There are tables and figures and statements made, but if you actually go into the report, which is what the TMDL, the Targeted Watershed Plan did, they reference two tables and text, and I would say that table 8.2 of the Little Pond MEP report, which is page 117, talks about if the inlet were widening, so that if the inlet were widening per the MEP report, you would still need to remove 100% of the septic load from the lower watershed, and I'm quoting from the report right now, plus inlet widening, so 100% of the lower watershed septic, inlet widening, and then 30% of the upper watershed. Now what that is a reduction from their baseline of 30% of the upper watershed septic. Not 30% of the septic, 30% of the upper watershed. And so if you do these calculations, which is what is in the report, what you find is that the total amount of kilograms that need to be removed to restore Little Pond are 5,000, in round, 5,000 kilograms. And the 30% of the upper watershed septic is about 600 and something, 600, where's my number, 602 kilograms. And so that's 12% of the nitrogen. And that's the number that we had calculated, when we presented this to the Little Pond residents, and that's in the targeted watershed plan for how we could get that last 12%. The inlet gets us 12%. And that's what the numbers and what the calculations and what the MEP report actually says. And I just wanted to clarify that so we all remember it.
This all relates to the town meeting where an article was in there arguing that we shouldn't have gone to Boyne's Pond, we should have gone to Little Pond to do an inlet opening, and Virginia, I thought, did an amazing job of presenting why Little Pond wasn't the one and why Boyne's Pond was.
You're just saying that because you didn't have to get up.
I had promised
He
not-
paid her to get up.
I had promised not to get up. And as I recall, when the vote was taken, the town meeting gave a unanimous vote against that article, including the proponent of the article who didn't even vote for it. So I think we, Virginia did a good job, and the town meeting recognized that.
Agreed.
Steve?
I'm not counting any of that. I just want to make sure I understand it. Whether you did inlet widening at Little Pond or not, you'd still have to sewer 100% of the lower watershed.
And that is exactly
No,
what the MEP
But,
report says.
but what is the difference of sewering or something in the upper watershed with and without the inlet widening?
The difference is either you sewer 60% of the upper watershed, or if you widen the inlet, you sewer 30%.
Okay. The reason I didn't, it's because 30 happens to be exactly half of 60. So when,
Precisely.
sometimes you're using 30 as the difference, and sometimes 30 is the result, and that's why I got confused. But
Right.
thank you, now I
Yes.
understand.
And that's why I like working in kilograms and not in percents at all.
Right.
Well, and does anyone have a figure on the fertilizer control percentage that would,
The
might-
percentage is 25%. The credit that we would get for that fertilizer bylaw is 25%. If you want to know how many kilograms that translates
No.
into.
State hasn't
well, we
given
get
us the credit yet.
25%, so then we don't
Make
have.
that
But,
clear.
yeah, Jerry is absolutely right. We do not have an official, the 208 plan hasn't been adopted, so there is no credit for fertilizer at all right now.
Okay.
And the 208 plan won't guarantee it. DEP has to look at what you have. They're the ones that give credit, not the
But if it were
208 plan.
25%, then we would reduce, the upper would go to 5%?
No, it's 25% of the fertilizer load,
Oh, 25
which is a few percentages of the
Okay,
total load.
that's what I-
It's
yeah,
a de minimis
No,
amount.
no, it's
It's
okay.
a small
okay.
percentage of a very small percentage.
Right, okay.
So there. Okay, any other comments or questions about the Little Pond Inlet issue? Everybody got the MSOA PowerPoint to look at?
I have to look at it.
Wacoit watershed meeting, the question on that was, remember the commission asserted itself as the agency that was going to pull everyone together to start talking about divvying up the costs and the
I
allocations
can
and all
update
that.
that.
And Jerry may be the only one who went to that meeting.
Well, I think Virginia was there. First of all, there is going to be another meeting next Thursday
Yes.
at 8:30 when they're going to go through charrettes or, you know, backing up. They're assuming there's going to be a mixture of approaches. The state's going to finally issue watershed-wide permits, probably to the town. And within that watershed-wide permit, there's going to be a menu of the things that the communities must do or should do, okay? Part of the discussion last week was that, according to the MVP model, they came out with certain calculations of loads attributable to each town, primarily Falmouth, Mashpee, and a little bit to Sandwich. There was a question that that number does not subsume what our TMDL requirement is. The TMDL requirement is still a load or target, but if we use adaptive management, we use some of the model estimates that the MVP gives us, we may get to, or 208 will say, we will get to the water quality before we have to meet the load required by the TMDL. The other part of that is trading. If the two communities could get together and say, if Falmouth has 60% of the load, they should pay 60% of the cost. And there will be a great deal of discussion on how money crosses town boundaries, if at all.
I have news, no money is crossing town boundaries from Falmouth to Mashpee to pay them to do things.
I just saying, this was the theory,
That's a political observation on my part.
and you were there.
Jerry, I was there. I think there was some confusion about the area which was being talked about when they decided how much Falmouth had and how much
Most, I didn't want to get into that, but yeah, you're right.
Falmouth had a much larger proportion than we actually have because they were using the western part of the area complete. They weren't using Quashnet, I don't think at all.
And they also forgot, and I don't know if they forgot, but it wasn't clear that the Papaneset, or there was a study, at least according to Mashpee, that they did, that didn't seem to be reflected in the nitrogen loads that the 208 put up there. I'm assuming they'll clarify that, because the next meeting's almost going to start off with some of the same requirements, but then they're going to get into like a watershed management plan.
Where is this meeting?
Mashpee Town Hall, 8:30, next Thursday, I believe. You should have got an invite.
I got an invite.
Yeah.
It was,
I think
Now, the only thing that the commission has to do in any time frame is name the responsible parties.
Yes.
And we presume Mashpee and Falmouth are certainly going to be responsible. Did the conversation get into the question of whether Sandwich was, or the base were going to be,
Yes, it did. It was all a complicated
and how far
discussion.
did they get on that?
Well, the base is not going to be designated a waste management agency, although it was clear that the base could be part of the solution, and there may be some non-point source runoff. Now, that's part of, the base was there, the deputy commander of the intelligent wing, as well as Carter Hunt, who's doing the wastewater planning for the base. So Sandwich does have a % responsibility. They're betting, or they're hoping, the people, because most of their nitrogen could be attenuated, we could pay for them to do something so we don't have to do as much. I should say that, the theory is that, that's low-hanging fruit that we could pay for.
Well, Sandwich's initial position was, we're not responsible for any of this. Is it?
I'm not,
Have they?
still
have
are.
I'm not going to speak for Sandwich or Mashpee.
No.
They have not changed that.
I don't think they've changed. They say the base is all of it, but other people pointed out there's some people living in Sandwich that are not on the base that are within the watershed that's concerned. But,
2,000 feet away. You're like,
well, yeah.
wrong way.
In terms of the allocations, Jerry, I just had a question for you. So MVP uses water use from 2012. And so you get kilogram numbers based on water use.
Mm-hmm.
And then you've got the MEP reports on which the TMDL is based. And what the net of it is that the present load is different. Did the commission talk about, were the regulators coming to a meeting of the minds on which numbers they're going to accept?
I wouldn't, they didn't, I would put it this way. The TMDL is set. That's the number we have to meet. The 208 goal, we could put in that we're going to do adaptive management to get up to the 208 goal. If we meet water quality standards, then the regulators will go away. But one doesn't, nothing subsumes the TMDL load.
So basically, we've got a planning guideline,
Yeah.
and we can use watershed MVP's numbers,
And,
which change that kilogram mass reduction,
Gotcha.
yes,
either up or down depending.
yeah,
One final question. Do we have a TMDL for Wacoit Bay?
no.
No, okay, so fine.
And
We're
there's that.
As far as I know.
ready to go. Well, I haven't heard it. You
Well,
haven't
Matt
heard
would
it.
know.
Okay.
TMDL for Quake Bay.
We have a draft.
we have tried
That's what I thought.
Yeah, great.
2 years ago, 3 years ago.
Yes. Well, everything takes time. Any other discussion? Any reports of members and committee staff? Steve and Ron?
The committee sent Wynn and myself to a cranberry nitrogen pollution meeting in Wareham on the 14th. And, do I win? If I do?
Yeah, well, you go ahead and say what you have to say. I'll add if there's
Okay.
anything I didn't.
I'll wait till here.
You were, I'll pick it up.
It was a good meeting. They didn't serve cranberries, but they had excellent chocolate chip cookies. But they also had good information. There were representatives from the Buzzards Bay Coalition, the UMass Extension Service, Chris Neal from the MBL, and a commercial cranberry grower. And the big difference is that they have dozens of cranberry bogs over there that all feed into one river system. We have about one. Maybe more, well,
The
peanuts
Cohasset
compared
River has
to,
quite a significant
Mr. River
Uh,
Jones?
They have
And-
really significant cranberries.
yeah, but compared to
Other parts of the
the other side of Buzzards Bay, we are insignificant. They had a map of the entire watershed, including Falmouth, and there were just red dots all over the place on the west side, and you had to strain to see any on this side.
So what are they?
The Wynn may disagree with this, but the data, they're doing a lot of studying of it. The data is all over the place. There are different kinds of bogs, different ways of running them, so on. One estimate is 11 pounds per acre per year.
Of nitrogen taken out.
Going in or coming out?
Coming out. I mean, that matters.
11
And
pounds.
another estimate is
Per acre.
2 pounds plus or minus per acre during the flood. which is in July. That's the other thing, it's very seasonal. They put the fertilizer on in July, and most of it comes right out.
And that's
And
only the surface water,
that's the surface water, that's right.
no groundwater.
But, and to my way of thinking, there are three bottom lines. One, our problem is peanuts compared to theirs. So this might be a place where instead of Falmouth leading the world and everybody else profiting from our expenditure on R&D, wait and profit from their experience in R&D, because they really have to do it. Two, it's probably small. Three, it will be in the MEP report.
Who's?
For Wacoit Bay, or wherever we have cranberry bogs in the estuary, in the watershed.
Great. Okay. Great Pond?
I may have said the wrong, where.
There is one,
It-
there is
it-
one in
Bill's done.
Lockwood Bay.
It's done. The MEP report is done, and cranberries are a contribution. And I thought what was interesting, although I wasn't there, I was at a sort of precursor meeting, where the sort of net was that the MEP report assumptions are being validated by the work that the coalition is doing now. And I think that was very important.
Yes.
That all of the, those summary documents that the MEP report has already done for cranberries, those numbers are being validated.
Right.
They
So,
use good numbers.
and,
I think that's
and the
important.
functional bottom line of that is that we don't need to do any additional research.
Nope, because we know what our numbers are, because those documents, the MEP reports are done.
That's a great recommendation.
I think it's also,
Let's
it's also
open up
worth mentioning that our cranberry bogs are flow of the river cranberry bogs for the most part, flow of the stream, where almost all of their cranberry bogs are not flow of the stream, but rather they are
Ponds.
constructed cranberry bogs, one way or the other. They don't, they don't,
So is
they're
it a
not-
higher number if it's constructed?
it's a little,
Don't
Depending
have.
on how many cranberries
I
there are.
only follow the MEP guidelines.
they only,
Ours are worse.
their test area is only 1% of the total cranberry bogs there. They don't know whether it's representative of all of them until they do a little bit more.
And they're
but-
studying it.
And they're studying it, so you can't answer that question yet. But they do have a different situation than we do. But I found it interesting that in the Agawam subwatershed gets 25% of its nitrogen, according to them, from cranberry bogs, that the Wankenko River subwatershed gets 57% from cranberry bogs. So they really have a big problem.
Big problem.
They have a reason to study it.
Good. Good. Right?
A couple things. One is that actually, C and I were both at the Northeast Coastal Acidification Network's workshop
yeah,
on coastal acidification. And so they were looking at what that means for us and for the Northeast. And it was interesting that Dick Krause gave a presentation where he's been measuring pH for the last 30 years, and it stayed between 8.1 and 8.2 the whole time. It's been very stable. And he actually runs his hatchery based on pH. And that, because as the animals respire, they create carbonic acid, then you get a drop in pH, and they need to spread them out into everything. So, he has a special way of taking Cape Cod Bay water over a weir, so it's good quality. They made a change, I don't know, 20, 30 years ago. So, but what was interesting that came out of it too is that basically what it came down to was that the issues that we're dealing with seem to be the critical issues. Okay, the eutrophication and things like this, not so much acidification in this area. It is something, it is a concern in some places and it is in others, but it more or less came down to that. I mean, eutrophication can affect, it affects pH a lot, but it's more of a biological thing. And the second thing that I just wanted to mention is that I was a little concerned for a while around April 10th and 11th, in that suddenly I had back-to-back tours to give about oysters. One to a group from Tufts that Scott Horsley is working with Scott Horsley, who wanted to hear something about shellfish and water quality, and then the follow-up one, which was my second year with Webner for high school teachers, where they bring in a group that works with Hui and goes to the wastewater treatment plant, goes to, I think, Eco Toilet Center, a lot of different places, including, so they're getting a full view on nitrogen issues. So, but then it was just back to back, and then, so it's quiet. Yeah, I was a little thinking like, okay, the phone will keep ringing, but it was, so it was nice that there's interest from various sectors. So.
Good. Okay. Any other reports or comments? If not, everybody got a copy of the minutes that were sent around earlier this week? Any additions or corrections to the minutes? If not, a motion to adopt the minutes would be gratefully accepted.
So moved.
Moved by Matt, seconded by Whit.
Yes, I have a suggestion.
What suggestion?
The discussion, that the record on Salt Pond showed that the idea of possibility of two different inlets
Oh, yeah,
was worth
that was-
considering.
that
Does that not make it into the minutes?
No.
It was a typo. It said, it should have been a knot, or the knot should have been removed.
No, I mean, there was a spirit,
I thought I put that in,
I mean,
It's
it's partly
in-
ego,
it's in
I
read.
came up
Do
with
you
the
have it right
idea,
there?
but there was a discussion about it.
yes, there was. And I thought let me grab these minutes, because I got them right here, the beauty of working on your computer.
That there should be
I
two inlets.
wasn't there, but there's
We
one
did
thing
the other,
I've seen.
the other meetings, all the other minutes are taken care of. You weren't at the
Nobody
last
said
meeting.
two inlets.
I wasn't there, but there were,
Yeah,
you know,
yes.
in terms of this
Oh,
topic,
I'm sorry.
I've seen systems where you can actually turn two inlets into a pump, and you put actually flap gates.
Exactly, that's
on
what
the-
it
That's
is.
what-
that's-
what
that's
it-
okay,
it-
that's
it-
okay,
it-
it
The
wasn't
two-inlet
there yet.
solution should definitely be in the
It, it did make it.
It did?
Yeah.
WQMC pointed out that looking at 1 versus 2 points of entry for enhancing tidal flow and circulation
Right.
should be explored.
I apologize, I should not
There it
have read.
is. Yeah.
One in and one
Thank
out.
you, and I was,
Okay.
you beat me.
So the minutes,
No, but doesn't that read, look at 1 versus 2?
1 versus 2 points of entry.
1 point of entry?
That
versus
means
two.
that it's 1 point of entry to
Right,
me.
1 point of entry is
Well,
what
the
we have
idea is
right
that
now.
you have
Goes
a
in one way,
valve,
comes out
so
the
you
other
have
way.
circulation.
Well, yeah, one
Yeah.
off.
If somebody has a specific way to change the
Yep.
sentence,
It doesn't,
Don't
it
give us
doesn't
an
don't.
interpretation. We'll be here for an hour.
That's what I thought was, I read it to what you.
Yeah.
All right, it sounds like
How about-
the meaning that the committee had is in these minutes. And unless somebody really wants to edit it.
I got an easy one. The water quality,
No.
WQMC pointed out that 2 points of entry for enhancing tidal